In this video, we are going to discuss about the propagation delay. On completion of this topic, the students will be able to describe the equation for source to drain current, the three regions of operation of MOS transistor. So first we are going to see about the RC delay model. So in this RC delay model, basically this propagation delay time is nothing but the difference of the input crossing the 50% and the output crossing the 50%. So of its maximum value, that is for worst case. So in the case of here we will be calculating the rise time and fall time. So for both the worst or the best case, the propagation delay can be determined from the corresponding values of this rise and the fall time. So first thing which is noted here is this RC delay model has the resistance, capacitance of the MOSFET, and is very important to decide the transient performance of the MOS circuits. So this RC model for single NMOS, it has k times than the unit size. So you can see it in the figure. This RN channel, that is it is the channel resistance of the NMOS, which is a function of the biasing voltage, and also it is given as Rn is equal to VDS by ID. In the case of linear region of the NMOS, VGS will be greater than VTN and VDS is greater than 0, but it is very small. Then this ID is equal to mu n into COX into W by L, VGS minus VTN into VDS. Hence this Rn value is equal to 1 divided by mu n COX W by L, VGS minus VTN. So from this, for the triode region of NMOS, this VGS is greater than VTN and 0 less than VDS less than VGS minus VTN. This is given as ID is equal to mu n COX W by L, VGS minus VTN into VDS minus VDS square by 2. And also in the saturation region, we can given as this VGS value is very greater than the VTN and VDS is greater than VGS minus VTN. So the generalized model of this channel resistance is independent of the operating region, so that we write it as Rn is equal to 1 divided by beta n into VDD minus VTN. This ideal switch and capacitance are on resistance. It has an unit NMOS, resistance R and capacitance C. PMOS has the resistance 2R and capacitance C. So NMOS, if it is R means PMOS will be having double the times of its resistance of NMOS. This capacitance is proportional to the width and the resistance is inversely proportional to the width. And the RC values is the capacitance C is equal to CG equal to CS equal to CD equal to 2, and this resistance is 6 kilo ohm. This is nothing but it improves the shorter channel effects. So here if we consider the unit transistors, it may be refers to the minimum contacted device, and also it may be 1 μm wide device, also doesn't matter as long it is consistent. So here you can see an inverter delay, that is estimate the delay of a fan out of one inverter. So if you see here, the two inputs NMOS is 1 and PMOS resistance is 2. So here it is given two inverters. So these two inverters are, the output of the first inverter is given to the input of the second inverter. So here this resistance, that is here this PMOS is replaced by a resistance, inductor and also the capacitance. So these 4, that is 2 PMOS and 2 NMOS are replaced by the circuits and it is given here. So the capacitance value of the that is NMOS will be 1 when compared to the that is 2 times, that is the PMOS capacitance. So finally you will be getting the resistance as this. We are replacing this by a switch RC2Z. So totally the delay will be 6 RC. Quiz questions on the propagation delay. Implement RC model of MOS transistor. Thank you.